So level 2 NCEA chemists, looking at our next functional group, that of the haloalkanes for our organic external. So the class name for the haloalkanes is the haloalkanes. The formula is CnH2n plus 1, where n is the number of carbons. And you've also got that X, which is going to be the halogen, which is from group 7. So X is going to be either a fluorine atom, a chlorine atom, a bromine atom, or an iodine atom. And the functional group essentially is an R, which is the alkane chain, plus, or alkyl chain, plus the associated halogen. So the suffix will be the ane, and the prefix will be your fluoro, chloro, bromo, and iodo, depending on what halogen is bonded to the alkane. So in terms of naming haloalkanes, the different positions for the halogen and branching of the carbon chain are noted. So basically you name it as the alkane, okay, and the carbon, which is the lowest of number, which is bonded to the halogen, is basically going to be the number that you're going to use. Okay, so the first one, it is 4 carbons, 1, 2, 3, 4, so it's going to be butane, and the chloro group is on the first carbon, so it's 1 chlorobutane. Okay, whereas in the second example, it's 2-chlorobutane because now it's on the second carbon. Okay, and it's important to note that the lowest number is the one that is chosen when you're doing this counting. Okay, so also if there's going to be a methyl or a different alkyl group, a methyl, ethyl, propyl group, etc., then you're going to have the halogen group taking precedence. It's going to go first in the name. Okay, so the one at the bottom there on the bottom left is going to be propane because 3 carbons is the longest chain, and it's also going to be 2-methyl because the methyl group is on the second carbon, and also 2-chloro because the chloro group is also on the second carbon. And in the case of the one at the bottom right, it's going to be 1-chloro-2-methyl propane because the halogen takes precedence in terms of a numbering system. It is on the first carbon of a 3-carbon longest chain, so it's propane. So therefore, because it's on the first carbon, the methyl group is said to be on the second carbon, hence it's a 2-methyl propane. Okay, now if you have multiple halogens on your halogen or haloalkane, then it takes precedence through alphabetical order. Okay, so it would be, for example, 1-bromo, 2-chloropropane, because bromo goes ahead of chloro in the alphabet. Also with haloalkanes, they can be known as primary, secondary, and tertiary. So essentially, primary just means that the halogen is bonded to a carbon, which is either bonded to one other carbon or a hydrogen, whereas secondary means that the carbon which has connected to the halogen is bonded to 2 carbons itself, and the tertiary is where the carbon that is bonded to the halogen is bonded to 3 carbons. Okay, the same applies when you're going to look at alcohols and amines as well. Okay, so there's really only one reaction that haloalkanes are involved in. That is their formation from alkanes, and that essentially occurs by treating an alkane with a halogen in the presence of ultraviolet light. That ultraviolet light then breaks up the halogen molecule into 2 halogen free radicals, which have a free electron. That free electron then goes on to react with a alkyl free radical and forms the associated haloalkane, as you can see in the green box. And you'll also notice there's a color change because methane and bromine. So bromine will have a yellow color, yellowy orange color, and then once the reaction occurs, you're going to have a clear vessel because methyl bromide is colorless, and so is hydrogen bromide. So that you'll see that color change occurs when the reaction has occurred. It's a test to see that if you've got a haloalkane formed from a alkane.